So, how's everybody doing out there? Well, welcome to day 4 of Corona Online School. So, hopefully, everybody did a good job on the 9.1 work and stuff like that. Or the 9.2 work, day 1. So, we're actually continuing along that line by doing some more 9.2 stuff today. So, we're going to be talking about triangles, and we're actually going to try to get into constructions. So, this lesson either has the potential to be super awesome or a massive disaster. So we'll find out here in a little bit. So if we were doing this in class, like everybody would have a protractor, everybody would have a compass, and it would be a struggle for some, but we'd all figure it out. But being that I don't know what people have. I don't know if people have protractors or compasses and stuff like that. I'm going to kind of demonstrate how to use these using some virtual tools that you can do. So see how you do. We'll try our best and we'll go from there. So let's start off talking a little bit about triangles. So we've done a little bit with triangles today. We're going to keep talking about triangles more and more. So the main thing you want to remember with triangles is you can actually describe them using sort of these 6 different classifications. So we can either talk about the measurements of the angles or we can talk about the side lengths. And so using kind of 2 words paired together, you can actually describe every single triangle. So acute, hopefully everybody remembers an acute triangle is one that is going to have all of the angles in the triangle are acute. So remember, acute angles are angles that are bigger than 0 but less than 90. So an acute triangle is a triangle where all angles are acute. So a right triangle right angle, remember, first off, is a 90-degree angle. So a right triangle is a triangle that has exactly one right angle. Oops. And we know it can't have more than one right angle because if it had 2 right angles, that would equal 180. And we know that's the maximum number of angles a triangle has in general. So that's why in this case, it has only one right angle. So same thing with obtuse. Obtuse angle, just remember, is an angle that's bigger than 90 but smaller than 180. So an obtuse triangle is a triangle with one obtuse angle. So perfect. So that's how we can talk about the angles related to different triangles. So now we can also talk about them in terms of their side lengths. So equilateral, so hopefully by looking at it and seeing this beginning part, you kind of hope it means something about equal, and that would be true. So an equilateral triangle, all 3 sides are the same length. So equilateral triangle, so another cool thing that we get out of that is we sort of get for free, if all the side lengths are the same, the angles are actually all the same also. And so it turns out in an equilateral triangle, all the angles would have to be 60 degrees. So if all the sides are the same, all the angles are the same. All right, so an isosceles triangle means that 2 of the sides are the same length. And then finally, scalene just means that none of the sides are the same length. So all right, perfect. So what we want to do is kind of using the information from above, what we want to do is identify each of these triangles by both names. So again, we want to use like right scalene, isosceles, obtuse, whatever it happens to be. We want to put both of them together. And so if you notice on these triangles, there's little tick marks. And so when there's two tick marks the same, like this and this, that means that those two side lengths are the same length. And so this one has two tick marks, and that means it's a different length in that case. So like over here, we've got one tick mark, two tick marks, three tick marks. So in that case, all the side lengths are different sizes. So kind of keep that in mind when you're looking through these. So I'll do the first one. I'll let you guys do the rest of them. So in this case, we've got two side lengths that are the same, and we've got one that's different. So right away, based on side lengths, that tells us we're going to have an isosceles triangle. And so what can I say about the angles? Are there any right angles? Definitely not. Are there any obtuse angles? Definitely not. So it appears all three angles are acute. So this would be considered an acute isosceles triangle. And you can do them in any order. If you say isosceles acute, that's fine too. Typically for me, I usually do the angle first and then the side length second, but you can do it in any order that you want. So I'll have you go through and do those couple on your own just to make sure we get comfortable with identifying the different parts of a triangle and how to label them. So this is where it gets fun and exciting. So again, if we had protractors and stuff, this would be easy, and it may turn out to be easier than I think. But what we're going to do is I'm going to use that same app I demonstrated before and show you how we can use this to actually construct different triangles using the protractor. So in this case, we wanted to draw a triangle that has a base of 4 inches and two angles of 40 and 60 degrees. And then we're going to classify the triangle by its sides and its angles in this case. So let me flip to the little document that I'd had in there. So the first thing we want to do is actually go ahead and draw our ruler first. It's kind of unfortunate this is crooked, but let me try to make it as straight as I can. And so, So pull it down here. So I'm going to make mine a little bit bigger than 4 inches because I don't think the 4 on here is really 4 inches. So I'm going to make mine a little bit bigger just so it works. So I'm going to go maybe out to 8 or something like that. So now what we want to do is we wanted, I think, a 40 degree and a 60 degree angle. So let me check just to make sure. Yep, 40 and 60. So now I want to grab my protractor. So let me hide the ruler. Grab my protractor. And so I want to come over here. Oops, it's spinning on me. So I want to pick it up. And so the nice thing about this app is that if you put a line down, it kind of lines up on the line. And if you go to the edge point, it kind of lines up on the edge. So I want to draw a 40 degree angle off of this side. So I'm going to get that ruler again. And in this case, I want to turn the ruler so that it's at 40 degrees, but I also have to make sure it's lined up down here on this bottom point. So I got it on the points. Let me shift it some more. So that looks like about 40. It's not quite on the dot. This doesn't have to be perfect. This is going to be hard enough as it is. So let me twist it just a little bit more. Oh, you got to be out on the edge to rotate it. There we go. Move it in. All right, I'm calling that good enough. Now, the main thing when you draw your line, just make sure you go far enough that we can actually, the two lines will intersect. So that's kind of the main thing you want to do when you draw this line. Even if it's too long, that's better than not long enough. So in this case, I made it ridiculously long, even though we may not use most of it. So now let me do the same thing to the other side. So now I want to draw a 60 degree angle. So just grab this protractor, run it along the line. Once it gets to the end, it'll stop. And so now I want to do the same thing. Let me rotate this ruler down. Rotate this ruler up. Kind of slide it around a little bit. Are we having fun yet? And then now I want to get this one at 60. So in this case, I need to go a little steeper. Oops, grab the wrong part of the ruler. So grab the top of the ruler so that way we can rotate it up. And that looks, well, it's on 60, but I don't have it on the bottom dots. Let me rotate the bottom a little bit. Alright, so I gotta move it a little bit. I'm so close. I was so close, now I'm totally off again. Told you this could be an epic disaster. Alright, I'm calling that good. So now again, just kind of sketch that down. And so let me get rid of the compass, get rid of the protractor. So I know this angle over here is 40. The one on the left is 40. The one on the right is 60. So my triangle that's left over in that case should be, from our triangle rule, so 40 plus 60 is 100. So it should be an 80-degree angle. And so it looks like we've got a nice acute triangle in this case. So let me go back. So classify the triangle by its sides and angles. So in this case, our extra angle would be 80 degrees. So that means all three angles are acute. So this is going to be an acute triangle. And so the thing to remember about side lengths is, remember, the side lengths are related to the angles. So if you've got three different angles, you're going to have three different side lengths. And if you were to go through and measure these, like, you could actually tell, like if I turn this around, so remember my bottom one I made around 8 or so. This one I drew over here. It's approximately about 5.5 or so. And then if I rotate this around and get the last one, so the last one's about like 7 and a little bit more than a quarter in that case. So either way, by measuring them, I can see that all three side lengths are different. So that tells me I'm going to have an acute scalene triangle in this case. And so if you wanted, you could, if you did this on the app, or if you were lucky enough and had a protractor at home, you could draw this right on the paper. If you use the little app or whatever, take a picture of it and maybe put the picture in the document so that way you've got a reference of it. So on your own, try number 2, see how you do on that one. And try 3, try 4, and try 5. So 4 and 5 we should be able to do either way, because you don't actually need the protractor for that one. If you want to try with the protractor, feel free. But the good thing is you don't need the protractor on those. You really just need to know a little about the 180 rule and stuff. So try those guys on your own. Pause the video at this point. Let me know if you have any questions with the app or anything. Otherwise, let's go to the construction section. So this is a lot of fun. And again, it's kind of unfortunate that we don't have compasses available, because this is kind of a neat way to do geometry, because this kind of takes you back to the way geometry was originally designed. So back in the super old days, back with Euclid and people like that, they did geometry with just a compass and a straight edge. Like, there was no measurements, there were no things like that, and they're able to just create beautiful accurate shapes and things like that. So could be a little tough with us using that same app that we were using. So the goal is, what I've got is, I've got a link for each and every one of these, like copy a segment, copy an angle, just so you can watch how it's done. If you happen to have a compass, like, you'll probably be able to do this no problem. If you don't have a compass, it could be a little tricky, but I thought what I would do is show you how to use the program by copying a segment. And then maybe we'll see, like, I might take a poll and find out how many people have a compass or how many people are willing. I wouldn't mind seeing people try and show me a demonstration of one of the 5 constructions we're going to do, because we're going to construct segments, angles, a triangle with given 3 sides, and a perpendicular bisector, and a parallel line through a point. So again, it could be that we won't be able to do this because of the technology, but we'll try it out and see. So, because again, it's kind of a cool thing. So in this case, copy a segment. So again, we have to do this without being able to like take a ruler, put it up beside it and stuff like that. So the only tools we have available are a straight edge. So imagine a ruler but with no lines on it, and a compass. So let me go back to the other program real quick. And let me clear this out. And turn off, well, actually I need the ruler to start off with. So again, pretend this ruler doesn't have any marks on it or anything like that. And so the idea is someone hands me a line segment of a certain length. So I'm just going to draw something here, and I'm going to use the other, I'm going to flip them around and use the other side so I don't actually know how long it is or anything. So I'm just going to draw a random line segment like that. And so let me hide this for the moment. And so now what my goal is, I want to use the compass to actually draw another line segment that exact same length somewhere else on the paper. So if I click the little compass button, so this one we have to learn to kind of move things around. So notice it's got a little lock button in the center. So if I hit the unlock, that's what allows me to make it longer and shorter and stuff like that. So once I get it to a right length, then I would hit the lock button, and then it kind of keeps it there. If I touch the metal part on the left, like that's the part that allows me to like move it around wherever I want to move it and stuff like that. And then if I want to draw, I actually have to touch the black part. And then the black part allows me to actually make my arc. So I just kind of spin it up and down to make my arc in this case. So let me get rid of that because I don't want to use that. So first thing I want to do is I need to measure this length using my compass. So I'm going to grab the metal part and go up to the end. And again, kind of like the protractor, it kind of locks in place on that last dot. So now I want to hit the lock, and I want to spread this guy out. And again, it kind of locks in place on the length of it for you too. So that is one of the nice things where a real protractor, it's a little tougher to do. And so now once you've got that distance, go ahead and lock it in place so it doesn't move. Grab the metal point, drag it down here into the middle somewhere. Put your hand on the black part, and so notice a little dot appeared on the left-hand side, so that means it's ready to strike an arc. So now just kind of go up and down to strike our arc. And so now we can actually remove the compass and bring the ruler back out, or the straight edge back out. And what we want to do is we want to line this straight edge up along the point, and then any other dot on that arc. So we can change this at an angle, it doesn't actually matter. And so now we just draw that line. And so lo and behold, what we've actually done is we've constructed a line segment that's exactly the same as the line segment above. So it's pretty cool. I mean, like I said, these constructions are a lot of fun. You may not find them to be as much fun with this app, even though it wasn't as hard to use as I thought. So what I want you to do, give these a shot. So if you happen to have a compass at home, look through these and stuff. And I'll talk about it in class, but I wouldn't mind like having everybody like make a video of themselves demonstrating one of them. So what I'll do is I'll probably assign everybody their own. So look in your what's due tomorrow folder, or what's due today, and I'll assign it. You won't have to actually present it or make a video, have the video of it ready until Monday, so that way you have all weekend to practice and stuff. Well, actually, I guess we don't have class on Monday. So until Wednesday, so you'll have all weekend to practice it and stuff like that. So it's not like you have to do it in class tomorrow. And that way you can work out some of the kinks, or if you happen to get a compass in the meantime, like you can actually do it with a compass. So I think that's it for today. So if you have any questions or anything like that, definitely let me know. Otherwise, have fun with it. This is actually supposed to be a really, really fun section, kind of a stress-free one. So let me know if you have any questions, and I'll see you tomorrow.